Alright, so we just made the C++ version. This is a Python video that we're about to do. It's independent of the C++ version, so you don't need to have made the C++ server or client beforehand. Let's go ahead and get started. So Python code will generally place in a folder called scripts. Executable Python programs will go in scripts. Library Python code, actually, you might actually put it in the source folder. It's kind of up to you how you want to organize it. But for now, let's write a script. So we'll write a landmark monitor server.py and add some of the boilerplate that's standard. So here we're creating a bare bones node. For reference, we can look at, let's just Google ROS service and look at the Python tutorial. Now in the tutorial they use a top-level function as the callback for what your service will, the callback that will implement your service. I prefer to call a class method because notice that if you need to share state between these two functions, it has to be in a global variable. And so with a class method, you can avoid that. So let's go ahead and set up a little bit of infrastructure. Let's create our class. So let's go ahead and create the signature that we're going to need. Another resource that is useful is to look at the ROS.py overview. The ROS.py overview has a little bit more detail than the tutorials do about publishing, subscribing, services, and everything. And we'll see exactly what the syntax is for doing so. So first we need to create our callback. So we'll create one for get closest. It needs to take itself if we're creating a class. And go ahead and just call pass. We need to import our types now. So to do this, you just say from tbotmessages.srv import get closest. We can also do get closest response as well. We're going to need that. And then since we are going to do both, let's also import get distance response. Just for now, let's do, we'll just do a log info and say closest called, and do something similar here, get distance. So this will print out the name. You'll notice that if you return none from your function, that will be interpreted as a failure. So in the C++ version, you return a bool, either true or false. In Python, you either return none or you return the response message. You can also return some other things, but I never do that. I'll just return the response message. So let's also do that. So we'll go ahead and return blank response messages for both. Next, we need to hook up our service. So we just say get closest is equal to rospy.service. This will specify the name on which we offer the service. And then we need to specify the type. So get closest in this case. And then we need to specify the callback. So first we'll need to create a landmark monitor. And then to specify the callback, we just say get monitor.getClosest. Okay, let's do the same thing for distance. I think it'd be helpful just to do a find and replace. And then update this. Before we can run this, we'll need to set the executable bit on our Python script. And now we can run our landmark monitor Python version. So it's running. Let me just clear this from the previous video. So let's try out some of the commands that we saw in the video. We can do ROS service list. And we can see our get closest and get distance are now in the ROS service list. We can get more information by calling ROS service info. And we can see that our landmark server offers this service. The service is of type tbot messages get distance. We can also do a cross-reference and do ROS node info on the name of the node, which is landmark server. And we can see that landmark server provides the get closest and get distance services. So that's just a useful debugging thing you can cross-reference. And then let's take a look at the type. You'll notice that it does tell you that name is an argument to the request, but that doesn't really tell you that much, so it's easier to use ROS serve show and then the name. And then here it will print out the request and response types, so you know exactly what they are. Pretty much this is a minimal example of how to implement a service. You can sort of put whatever code you want in here. For the rest of this video, we'll try to make it more interesting and just make it actually do what we said it would. So let's go ahead and start with that. All right, so first we'll need to create our landmarks, a hard-coded set of landmarks, which I have here. All right, so here landmarks will just be a dictionary that maps names to XY positions. We'll also need to store the X and Y position of the robot, current X and Y position of the robot. To get the current X and Y position of the robot, we'll need to look at the robot odometry. So let's start up our Gazebo simulation again. So if we look at the topics, there's an odom topic. Let's get some more information about it with ROS topic info. You'll see it's of type nav messages odometry. And we can take a look at a sample message by just getting a single message. And you can see that the position of the robot will be in pose.pose.position.x and y. So we'll need to go ahead and import that. Let's also take a quick look at the ROSPy tutorial for a subscriber. Let's create a callback first in here. We'll call it odom callback. And then we'll set our X and Y. I usually find in Python it's a little bit harder to figure out what all the types are. You'll have to reference tools like ROS topic echo, or you could do ROS message show on nav messages odometry. And it shows you you have to do pose.pose.position.x, for example. Now we need to actually subscribe, so let's do that. Subscribe to the odom topic. So type odometry, and then the callback will be monitor.odom callback. Now let's implement get distance. We're simply going to look up a landmark in the map, so let's do that. So get distance, the request type takes in a name, landmark name, so that's just going to be .name. So remember, looking back at tbot messages, get distance. We take in a name and then we have to return the distance. So we'll check first if it's in the landmarks. If it's not, then we'll say, we'll print out an error message. And we'll also go ahead and return none to indicate an error. Otherwise, we can compute the distance. We'll need to import math in order to get the square root function. And then we'll do response.distance is equal to math square root dx times dx plus dy times dy. Okay, so that will return the distance. We'll go ahead and do get closest as well. So get closest doesn't take in anything. Instead, we'll just iterate through our landmarks. Here I've made a very common mistake. I always make this mistake when iterating through dictionaries. Okay, so we've iterated through the dictionary, computed the distance, kept track of the best distance and the best landmark, and now to return that answer we need to set response.name to the best landmark. So I think that's everything for right now. Let's test it out and see if we've done this correctly. So right now, if we look at this, it looks like the Turtlebot is closer to the bookshelf. It's also kind of close to the cube, but we'll find out. So let's run our server again, and let's call our service again. So let's try getting the closest one. It says the bookshelf is the closest. Let's see if we can double check this based on the distance. I'm going to hit tab twice, and it will give me a little auto completion here. I need to fill in the name. Tells us that the distance is about half a meter. Now let's compare it to the cube. Tells us that the cube is about a meter away, so the bookshelf is indeed closer to the cube, or closer than the cube. We can also try driving the robot around just to double check. So let's do ROS launch Turtlebot teleop keyboard. So let's drive this towards the cube. Okay. And now let's try this again. So let's try calling get closest. Now it says that the cube is closer. So let's get the distance to the bookshelf. We're now about 1.6 meters away. If we look at the cube, we're now about 24 centimeters away. So we are indeed closer to the cube. Lastly, let's also try an invalid landmark name. So let's just put an ASDF. And you can see we got an error here. And the error gets printed out to the console on the server side. So this concludes the implementation of the Python server. Next, we'll implement a Python client. All right, so let's implement the Python client. We'll create another script. We'll call this landmark under client.py. And we need to set up our boilerplate. We are not going to include a ROS.py spin because, well, I haven't explained what we're going to do with this client. I think what we want to do with this client is essentially print out the closest. It will print out the closest landmark, like cube, and then it'll print out all the landmarks and their respective distances, like this or something, and so on. So since this is a simple utility, it just gets the answers and prints everything out. We don't need a ROS.py spin. The ROS.py spin is just an infinite loop that processes all the callbacks, so it's only useful if you have a node that you want to keep running forever. So we're just going to get rid of that. Let's go ahead and implement the calls. We can just reference the tutorial in this case on how to do it. So we'll need to import our messages. I'm going to do this in a little bit of a different way, just to show you the different ways that you can import the messages. So here, in the last video I did from tbotmessages.srv import get closest request or something like that. here I'm just going to import tbot messages, so I'll show you an alternate way to do the imports. It's up to you how you want to do it. So first thing we need to do is create a service proxy. And the service proxy is essentially, you can actually, you'll see, you'll be able to treat this like a function call, this return value as a function call. So we need to say, first of all, the name of the service that we want to call, and then the type of the service. So we're going to say tbot messages.srv.getClosest. If you just say import tbot messages, then you'll have to write this whole thing out every time. On the other hand, if you do, as you saw in the server implementation, you can also just do something like this, in which case you only have to, you would only have to say get closest instead of tbot messages.srv.getClosest. Sometimes this is helpful, like you want to be able to see this full thing in your code so that you're not confused about what types are coming from where. Let's also create a service proxy for getDistance while we're at it. Now, in the tutorial, you'll see that they pass in the arguments to the request directly. And so there are actually multiple ways that you can call the service, and that again is going to be detailed in the ROS.py overview on services. So that's why I like looking at this page more than the tutorials. So you'll see that there are a couple different ways that you can do this. There's the explicit style, where you first create a request type and then you call with the request type. You can also pass in all of the arguments in the same order that they're defined in the service file, this is the way they do it in the tutorial. And then there's this other style where you can pass in arguments using keyword arguments in Python, and then anything that you don't specify in the keyword arguments will be assigned a 0 value. So I really prefer the explicit style. So one of the reasons why I don't like the in-order style is that if you ever change your request type, let's say you add a field to your request type, you're going to have to find in your code all the places where you called that service, and you're going to have to update this. Whereas if you do the explicit style or the keyword argument style, you don't have to do that. Just anything that you haven't filled out will be given a 0 value by default. Okay, so let's go ahead and do this with the explicit style. So the explicit style basically just means you are creating a request. So we have to say tbot messages.serve.getClosestRequest. And in this case, actually, there's nothing to fill out in the request because getClosest doesn't take in any arguments in the request. So now we can just call it getClosest, and we'll give it the request. And then we can print out the closest. Let's also import the print function so we can use this. Now let's do get distance for all of the landmarks. So I'm just going to hard code the list of landmarks here. Okay, so again, we're going to use the explicit style. I'm going to create a request, and then we're going to call get distance with that request. But we do have to fill out something in the request, which is the name. So that's going to be the landmark name. And then we'll get the answer in the response. And here we don't have enough type information to autocomplete. But basically this is a get distance response, which if you remember just has a single distance field in it. So I think that is everything that we need to do. Let's also mark this script as executable so that we can call it. All right, let's take a look at our simulation world again. So we drove the Turtlebot a little bit closer to the cube. So now let's try ROS run tbot landmark monitor client. Okay, so I apologize because for most of the video I just explained how to do this method. And I think this is actually the right way to do it. So let's try this again. Yes, okay. So sorry about that. You can't just import tbot messages. You have to import tbotmessages.srv in order to do this style. Or you can use the style that we used for the server. But here you can see the cube is indeed the closest, and I think these numbers are similar to what we saw before. So it looks like everything's working. Another thing that you'll want to look at is, and it actually shows up in the tutorial here for Python, is this wait for service function. So this is very useful because sometimes you'll launch a server and you'll also launch something that uses the service at the same time. And the client might start up and call the service before the server starts up. And so you'll fail that call. So if I go ahead and shut down the server, but I call the client, for example, we're going to get all these errors here. So it's useful to call this wait for service. I think it's also listed here. So wait for service, if you just call it with no timeout, it'll wait forever for the service. But I prefer to specify a timeout and to just exit the program early if it doesn't exist. So let's go ahead and wait for the service. And we'll set the timeout equal to wait, so we'll wait for 5 seconds. And then if the timeout is exceeded, then it will raise a ROS exception. So we'll need to handle that. And we'll just print out an error. Services did not come up within 5 seconds. And we'll just exit the program early. So right now we're not running the landmark server, so let's try this. And you can see we waited for 5 seconds, and we just print out an error message if the services didn't come up. On the other hand, if we go ahead and just run the server, then it waits a little while, and then as soon as the server is available, it calls the server, and we get the same results. So I definitely recommend using wait for service, preferably with the timeout, and that will make your system a lot more robust. The last thing I wanted to mention is that C++ and Python are interoperable when it comes to services. So we've created a Python server here, but we can also call our C++ client and get the same results. We can also run the server, the C++ server, and call the Python client. And again, we'll get the same results. So you can use C++ and Python interchangeably when it comes to the client-server architecture. And that's one of the reasons why you'll use a service in the first place. Okay, with that, I think that concludes our video on implementing services in Python. So I'll see you again in the next video. Thanks very much.